Hey guys, Mrs. Traber here. Today we're going to talk about the quadratic formula. Our learning target is to be able to solve equations with that quadratic formula, and to do that, you'll be successful when you can substitute a, b, and c into that equation. Let's jump in and first talk about what it's like to solve a quadratic, what that actually means. So a quadratic formula is one that has an x squared term with degree 2, and the picture of it on the graph looks like a parabola. So it's that u or upside down u sometimes. There's 4 ways to solve quadratics. You can graph them like this and then see the solutions. You could factor them, you can complete the square, or you could do what we're doing today, which is the quadratic equation. Now, when you're graphing them, the equation goes through the x-axis at 2 different points in general, here and here for this one. So I can kind of see this looks like it's in between 0 and 1, and I can kind of see this one looks like it's at -2. So with graphing, it only works if you have a very precise graph and you can tell for sure that it's going through that point. Factoring doesn't work for all quadratics, and completing the square is sometimes cumbersome to do if it doesn't work out right. The quadratic equation, though, works no matter what, so it's the foolproof method that will work for every single quadratic. You can either get 2 solutions like this one has. You could also have a situation where your graph touches the axis at just one spot with one solution. And you could also have the situation where maybe your graph doesn't touch the x-axis at all, and there's 0 solutions. So there's 3 options for types of answers here. We're going to do some examples moving forward. Here's the same one we had just seen, 2x squared plus 6x minus 8. And we already have an idea that this should be in between 0 and 1 for one of the solutions and at -2 for the other. Let's use the quadratic formula in order to solve it for sure. Now here is the formula. It looks pretty crazy, but this is the formula we can use. In a different video later, I'll describe how to get this formula, how to derive it. It's actually the proof behind the scenes of why in the world this works. And I'll give you a hint, it has to do with the Pythagorean theorem. That's why there's A's, B's, and C's in them. Speaking of A's, B's, and C's, I want to show you what those letters correspond to. So this equation is in standard form, meaning standard form is ax squared plus bx plus c equals 0. So specifically, it's set equal to 0, and a is the coefficient on x squared, b is the coefficient on x, and c is the constant. So what we really just need to know is what a, b, and c are. So my advice to you each time is to write the standard form above it, and then you can kind of just circle what the letters are. So a is 2, b is +6, and c is not just 8, it's -8. So make sure when you're doing this that you circle the negative in front. Now these two are positive, so I didn't have to. So I've got a is 2, b is 6, c is -8. All we have to do now is plug those values into this equation and plug it in and go. So let's do that. X equals -b, so that's -6, plus or minus the square root of b squared. I'm going to use a parentheses with that. Matter of fact, I'm always going to use a parentheses here. It's important specifically when b is negative, but I just want you to get in the habit of it, so I'm going to do it every time. So b squared, I'm going to put parentheses around 6 and then square it. Minus 4, and then I usually do this and put parentheses around both the a and the c to show where they go. So a is 2 and c is -8. Everything is over 2a, so that's 2 times 2. So again, notice whenever I'm plugging things in, I generally just use parentheses. That way I can make sure everything looks good. Next, I just want to use my calculator to make this work. So let me show you the best way to go about that. Here is the decimals calculator. My advice to you is to take this piece by piece. So what I'm going to do first is type in everything that's underneath the square root. So I'm going to do the square root of, and then I'm typing it exactly as written, literally exactly as written. That's important that you do that. Your calculator can do PEMDAS, but I go step by step, so it works out. So I put the entire thing in the square root here, and I got a 10 out. So I'm literally going to just rewrite this, but instead of that whole square root, it's 10. So I'm putting a 10 there, and then I can do this part in my head. 2 times 2 is 4. Once you've cleaned it up to this point, we did a lot of simplifying from step 1 to 2. The plus or minus means you're doing this problem twice. You're doing it first with plus, and then you're doing it a second time with a minus. So we'll get 2 answers on this one. -6 plus 10 is 4. 4 over 4 is 1. -6 minus 10 is -16. -16 divided by 4 is -4. So there's my 2 answers, 1 and -4. Going back to our graph, we said our answer we thought was going to be at 1/2 and -2. Notice these are actually counting by 2s. I didn't notice that off the bat. So this is 2, 4, 6, 8, 10. So there's our answer at 1. Here's our -2 and -4. So there's our answer at x equals 1 and x equals -4 for our two answers. So how I'd write it is x equals 1 and -4. I'm literally going to write the word and. Let's do another. Here we go. In this case, A is 4, B is 12, and C is -27. Let's plug them in. X equals -b, so -12, plus or minus the square root of b squared, so I'm going to do parentheses 12 squared, minus 4, and then I can plug in my A and my C. Everything is over 2a, or 2 times 4. Now I want to pause here and mention, because you might be getting a little bit scared that I'm going to make you memorize this formula. I am not. Anytime I give you a quiz or a test, I will give you this formula. Matter of fact, my reasoning for that is because the SAT does the same thing. In the SAT, in the very front page, there's a list of formulas, and this is one of them. So if they don't make you memorize it, I'm not going to either. That's why I'll have it up on every single slide. Let's clean this one up. I'm going to type everything in with that square root next. So here we go. We've got 12 squared. Oops, I forgot my square root already. Square root of 12 squared minus 4 times A times C. I get 24. So I'm going to rewrite this, and inside that square root, everything that had turns into 24. So -12 plus or minus 24 over 4 times 2 is 8. Now I'll write this out twice. -12 plus 24 over 8, and -12 minus 24 over 8. -12 plus 24 is 12. 12 over 8, I can simplify. They both are divisible by 4. So if I do that, then I'd get 3 over 2. So 3 over 2, or 1.5, is one of my answers. The other one, -12 minus 24 is -36 over 8. Again, these are both divisible by 4. 4 goes into 36 9 times, and it goes into 8 twice. So 9 over 2 is 2, 4, 6, 8, 4.5. So my answers here are x equals 1.5 and 4.5. Let's do another. This one looks a little bit different, and I wanted to mention it to you. So as a reminder, our standard form is ax squared plus bx plus c equals 0. And as a reminder, a goes on x squared. So we've got these here, but same thing. That means a is 6. B is the term in front of x. Now, I don't see any x's here. If you don't see any x's, that means our b term must be 0, because there's no x's, or no v's, I should say. So it's sort of like as if it was written with 0v. Lastly, c is the number that's by itself, which is -54. So I've got a is 6, b is 0, and c is -54. Let's try this one out. X equals -0, yes, you heard me right. I'm just going to write 0, though, because writing a negative in front of 0 seems painful. So 0 plus or minus the square root of b squared, so that's 0 squared, minus 4 times a times c, all over 2a. Let's clean this up. The 0 thing is weird. This whole part's going to go away. So is this part. So really it's going to be the square root of -4 times 6 times -54 over 12. And then let's clean up that whole top. Oops. So we have the square root of -4 times 6 times -54, which is 36. So the whole top is 36. 36 divided by 12 is 3. So in this case, I only have one answer, which is particular because of the fact that there actually was no b. That happens every time that their b is 0. So in this case, only one answer, x equals 3. I should mention there is an easier way to solve this equation, to be honest with you, and that totally works for me as well. But this video is about quadratic equation, so I didn't show it to you first, but I can't not show it to you now. So going back to the original problem, if I had simply noticed that I could solve this like a normal problem where I I added the 54 over, and then I divided by it, I would have had v squared equals 9 and taken the square root to get my answer 3 as well. So same thing. Here's the next one. We've got an a is 3, b is negative 6, and c is negative 13. Let's plug these guys in. X equals negative b, and let me be careful here, negative from the formula, and then b is negative 6, so negative negative 6. I'm going to write it like that first, just so we can make sure we get it. Plus or minus the square root of parentheses, b squared, so that's negative 6 quantity squared. Make sure the negative is in the parentheses. Minus 4 times a times c. And then we're all over 2a. Let's clean this up a bunch. So we've got the square root of parentheses negative 6 squared minus 4 times 3 times negative 13. So on this part, I got 13.86, I'll say. I had negative negative 6 plus or minus, so that's really positive 6. So 6 plus or minus our decimal piece all over 6. Let's do this twice. And I just want to mention here, you can kind of use the shortcut in your calculator by typing it in twice. So if I type it in the first time, 6 plus 13.86, and if I type it in all at once, that whole top divided by the bottom, you get your first answer, 13.31, or I'm sorry, 3.31. And then you can just use this to go back and change it to a minus, and it'll tell you the other answer, negative 1.13. So there's my two answers to this one. My next one, I've got a is 6, b is negative 5, and c is negative 8. So I've got x equals negative b, so negative negative 5, plus or minus the square root of b squared, I'm putting the negative 5 in the parentheses, minus 4 times a, which is 6, times c, which is negative 8. All over 2a, so that means all over 2 times 6. Negative negative 5 turns into positive 5. Let's clean up that square root. So I've got the square root of negative 5 quantity squared minus 4 times 6 times negative 8. So 14.73. Lastly, let's plug this in with our two answers. So we've got, whoops, I don't know why it keeps doing that. Go over there. Let's see, I'm going to use the parentheses for my numerator. So 5 plus 14.73 over 12 gives me 1.64. And the other one, I can just now change this to a minus, negative 0.81. There's my two. Alright, so I couldn't let myself get to the end of this video without showing you my favorite thing ever, which is, I know I told you you don't have to memorize this formula, but I have to show you this video. I just have to. I have to show it to you. So without further ado, here is the quadratic equation as a song that is super obnoxious, but you're going to love it. So just listen along and see how this goes.
X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a.
So as you can see, I could not let you go without showing you that beautiful video. That's all I've got for quadratics today. I hope you have a good time with it, and I hope it's not too scary. I know the equation looks a little bit daunting, but it's not as bad as it looks. Just use parentheses and plug things in. Let your calculator do a lot of the work for you, and you'll be all set. I'll see you next time, guys. Bye.